Welcome back with Professor Stephen Williams of Southern Technical College, talking about Chapter 7, Part 4, Latching Relays.
Latching relays, as the name applies, they operate and then they latch and stay in the position that they're in. Basically, they've got some kind of a mechanical catch or sometimes two coils. In other words, one to latch it, one to unlatch it. Okay, so with that in mind, one of the real good purposes for it is if you have something that you don't want it to change, if you lose power, okay, a latching relay will stay in whatever position it's in until it's told to close via a signal to it, okay? Without that signal, it's going to stay closed even if it has no power to it. The coil being de-energized doesn't affect it at all. Okay, so that is a latching relay. Let's look what else they have to say about it. Mechanical latching. You can see here there's a picture of how that mechanical latching would work. Okay, use the locking mechanism to hold the contact in its last set position until commanded to change state by using an energizing of a second coil. Okay, two-coil mechanical latching relay. It's what they look like. And again, uncommon. They're not. But then again, I could think of a lot of reasons why you'd want to have it. I don't run into it very often with the control circuits that I've gotten involved with. I don't know if it's going to actually work. I don't see it working.
Maybe because you're on the Apple.
What happens is you turn it on, the relay changes state, okay, it latches, you've got a coil that latches it, and whether this power is here or not, it's going to stay latched until such time as power is restored and it's told to unlatch. All right, and it'll sit there for years at that position and will not restore. Magnetic latch. Magnetic latch, typically a single coil relay designed to be polarity sensitive. When voltage is applied to the coil with a predetermined polarity, it will latch. Okay, same as the mechanical. And then a permanent magnet that holds the contact into the latch position. When the polarity is reversed, the current is momentarily applied to the coil, and the armature will push away from the coil, overcoming and holding the effect of a permanent magnet, causing the contacts to unlatch or to reset back to their original condition. Okay. Same basic principle. As far as it's concerned, it's got similar operation. Difference is it only has one coil versus the two coils. But you still got a latch and a reset position. Unfortunately, I can't get these things to work, but you could see how that would be interesting if you wanted a timeout, for example. Your assembly line, okay, has a problem and you want to shut down the assembly line and you don't want it to change positions, so you push a relay and the power comes back on and all of a sudden, boom, it starts back up again. Well, by having a latching relay, you can block that signal and it won't come back even if you lost power until you're ready to start the thing back up and you push a button to tell it to go back again. Low voltage latching relay, they use them in lighting contactors. And again, interruption after power interruption, because you want the lights to come back on, stay on when the power returns. Okay? Obviously, if your house power went out, you'd want the lights to still stay on. But if they were powered by a contactor, that once the coil is de-energized, it's going to reset the contacts. Well, your lights don't come back on until you go back there and push them into working again. So anyhow, just different examples in here, and unfortunately it's not a very user-friendly
Not with the
PowerPoint that I've
Mac.
got here. All right, so that's about all I can tell you about latching relays. There's not much more to know about it. You can do the same thing with an electronic type relay. Doesn't necessarily have to be mechanical, because again, a relay will do what you can program anything into an electronic relay. All right, with that in mind, we're done for tonight, and I will hopefully see you later.